In this video, we are going to discuss matrices, exercise 3a. The questions are given. First, write the following as a single matrix. So, the questions are given like this. Now, the solution is here given. First one solution. See, we have to write as a single matrix here. The solution of the first one. See, here this is a 1 by 3 matrix. This is 1 by 3 matrix, and this is also 1 by 3 matrix. 1 row, 3 columns. So 2 plus 0 corresponding elements are adding here. 1 plus 0 and 3 plus 0. 3 plus 0. Finally we get, so here 2, 1, 3. So this matrix's order is also 1 by 3. So similarly, solutions these are. So second one solution. So second one in this, so given this is 3 rows we have, so 3 by 1 matrix, and here also 3 by 1 matrix. Both the matrices have the same order. So adding corresponding elements. So here 0 plus minus 1, and here 1 plus 1, 1 plus 1, next minus 1 plus 0, minus 1 plus 0, we get here, so we get here 0 minus 1, that is minus 1, 1 plus 1 is 2, and this is minus 1, so order of this matrix is also 3 by 1. Next, the third one is here, so the matrices are given here 2 rows and 3 columns, here also 2 rows and 3 columns. The resultant matrix order is also 2 rows and 3 columns only. Adding the corresponding elements here, 3 plus 4 and 9 plus 0, 9 plus 0 and 0 plus 2 here, 0 plus 2. So next 1 plus 7, 1 plus 7, and here 8 plus 1, 8 plus 1, and here minus 2 plus 4, minus 2 plus 4. So we get here, which is equal to 3 plus 4 is 7 and 9. So here 0 plus 2 is 2 and 1 plus 7 is 8. 8 plus 1 is 9 and minus 2 plus 4 is 2. The resultant matrix order is also 2 by 3. Similarly here the fourth one is we have 3 rows and 2 columns. Here also one more matrix. So 3 rows with 2 columns. We have to add both the matrices. Both the matrices have the same order. So that's why here adding the corresponding elements, here minus 1 plus 0, and here so 2 plus 1, 2 plus 1, next here 1 plus minus 1, 1 plus minus 1, and here minus 2 plus 0, minus 2 plus 0. So here 3 plus minus 2, 3 plus minus 2, and here minus 1 plus 1, minus 1 plus 1, which is equal to, so we have minus 1 plus 0, that is minus 1, and 2 plus 1 is 3, and here 1 plus 1 minus 1 gets cancelled, 0, minus 2 plus 0, that is minus 2, and here 3 minus 2, that is 1, minus 1 plus 1 gets cancelled, 0. See, the resultant matrix order is also 3 rows and 2 columns. Like this we can prove. The next question is, if A is equal to matrix minus 1, 3, 4, 2, B is equal to 2, 1, 3, minus 5, and X is equal to X1, X2, X3, X4. So now we have to find the values of X1, X2, X3, X4, and the condition is given A plus B is equal to X. So here in the given problem, we have A, B and X matrix. So if you observe that here all the matrices are order is 2 by 2 only. So 2 rows and 2 columns only. So A plus B, given that A plus B is equal to X. So A plus B is equal to X. So that means add both the matrices here. So the corresponding element, that means minus 1, 3, 4, 2. This is matrix A plus matrix B is 2, 1, 3, minus 5. 2, 1, 3, minus 5, which is equal to matrix X is already given x1, x2, x3, x4. So now adding the corresponding elements in the matrices, both the matrices order is 2 by 2 only, and this matrix order is also 2 by 2. So we get here adding the corresponding elements minus 1 plus 2, so 3 plus 1, and here 4 plus 3, so here 2 plus minus 5, 2 plus minus 5, so which is equal to, we have x1, x2, x3, x4. So here we get that minus 1 plus 2, so which is equal to, this implies we get here 2 minus 1, 1, and here 3 plus 1, 4, and here 4 plus 3, 7. So here 2 minus 5, that is minus 3, so which is equal to the matrix x1, x2, x3, x4. After adding the A and B matrices, we get 2 by 2 matrix here. Already we have, this is also 2 by 2. So both the matrices are equal. Equate the corresponding elements to get the values of x1, so x2, x3, x4. So now therefore x1 is equal to here 1. So x2 is equal to, the corresponding element is 4. x3 is equal to 7. And x4 is equal to here minus 3. Like this we can find the values of x1, x2, x3 and x4. The next problem is, if A is equal to minus 1, minus 2, 3, 1, 2, 4, 2, minus 1, 3, and B is 1, minus 2, 5, 0, minus 2, 2, 1, 2, minus 3, and C is equal to minus 2, 1, 2, 1, 1, 2, 2, 0, 1. See, we have to find the sum of A, B and C matrices here. So A plus B plus C is equal to here. So all the three matrices order is same only here. Minus 1, minus 2, 3, 1, 2, 4, and 2, minus 1, 3. So this is 3 by 3 matrix. And plus, again the B matrix is 1, minus 2, 5. So 0, minus 2, 2, and 1, 2, minus 3. This matrix order is also 3 by 3. And plus, again the matrix C is minus 2, 1, 2, and 1, 1, 2. So 2, 0, 1. So this matrix order is also 3 by 3. So to get the A plus B plus C, the corresponding elements of these three matrices we have to add here. Minus 1 plus 1 here corresponding element, here plus minus 2, and here minus 2, and here plus minus 2, and here plus 1, and the third element is 3 plus 5, and here plus 2. So now here in the second row, the corresponding elements are 1, so plus 0, here first element is 1, and again here 2, here second element is plus minus 2, and here the second element is plus 1, and third element is 4, and here plus 2, and here plus 2. So next in the third row, so first element is 2 plus, so 1 plus 2, so again here, so second element minus 1, here second element is 2, so in this corresponding element is 0, and here 3, so the second element is minus 3, and here the third element is here, third element is minus 3, here also third element is 1, like that corresponding elements we have to add. So now which is equal to what we get. See, plus 1 minus 1 gets cancelled here, minus 2, and here minus 4 plus 1, that is minus 3. So 3 plus 5 plus 2, that is 10, and here 1 plus 1, that is 2. So here 2 plus 2 minus 2 gets cancelled, 1, and 4 plus 2 is 6 plus 2 is 8. So here this is 5, and here 2 plus 2 minus 1, that is 1, and plus 3 minus 3 gets cancelled, this is 1. So the order of resultant matrix is also, we get 3 by 3, like this we can add the matrices. The next question is, if A is equal to 3, 2 minus 1, 2 minus 2, 0, 1, 3, 1, B is equal to minus 3 minus 1, 0, 2, 1, 3, 4 minus 1, 2, and X is equal to A plus B, then find X. So how to find here? Given that the condition is given that x is equal to a plus b, x is equal to sum of the matrices A and B, so which is equal to, so now 3, 2, minus 1, the matrix A is writing here, 2, minus 2, 0, and 1, 3, 1, and plus here the matrix B is minus 3, minus 1, 0, and here 2, 1, 3, so 4, minus 1, 2. So now adding the corresponding elements, here 3 plus minus 3, both the matrices order is 3 by 3 only here, both the matrix order is 3 by 3, so adding corresponding elements 2 plus minus 1, and here minus 1 plus 0, so then we get 2 plus 2, so here minus 2 plus 1, minus 2 plus 1, then 0 plus 3, 0 plus 3, here 1 plus 4, and 3 plus minus 1, 3 plus minus 1, here 1 plus 2, so which is equal to we get, so here plus 3 minus 3 gets cancelled 0, and 2 minus 1, that is 1, and minus 1 plus 0, that is minus 1, and 2 plus 2, this is 4, and here minus 2 plus 1, that is minus 1, so here 0 plus 3, that is 3, and 1 plus 4, which is 5, so 3 minus 1, that is 2, 1 plus 2, that is 3. See here, the resultant matrix order is also 3 by 3. So like this we can find X matrix. So the next problem is if x minus 3, 2y minus 8, z plus 2 and 6, this matrix is equal to 5, 2, minus 2, a minus 4, then find the values of x, y, z and e. Now here if you observe that two matrices are given, so both are 2 by 2 matrices only, x minus 3, 2y minus 8, z plus 2 and 6. So two matrices are equal means their order must be same, and also so their corresponding elements are equal. So to find the value of here corresponding element, to find the value of x, so now x minus 3 is equal to 5 here, the corresponding element. So from this, so x is equal to 5 plus 3, which is equal to 8. So that implies x is equal to 8. So similarly here corresponding element is 2y minus 8. So which is equal to here corresponding element is 2. So that's why from this to find the value of y, 2y is equal to here 2 plus 8. From this 2y is equal to 10. From this y is equal to, this implies so 10 by 2, so which is equal to 5. So that implies y is equal to 5. So similarly here next corresponding element here in the first matrix is z plus 2. So both the matrix order is same only here. So z plus 2 is equal to minus 2. And from this to find the value of z, so z is equal to minus 2 and again minus 2 here. So which is equal to minus 4. So that implies z is equal to minus 4 only we get. So again to find the value of a, here corresponding elements are 6 is equal to a minus 4. From this a is equal to 6 plus 4, so which is equal to 10. So that implies a is equal to 10. So like this we can find the values of x is 8, y is 5, z is minus 4 and a is 10. Next in the section 2, first one is if a matrix x minus 1, 2, 5 minus y, 0, z minus 1, 7, 1, 0, a minus 5, which is equal to matrix 1, 2, 3, 0, 4, 7, 1, 0, 0, then find the values of x, y, z and a. Here if you observe that the given two matrices are equal here, so their order is also same. So 0, z minus 1 and 7, here in the third row 1, 0, a minus 5, so which is equal to, here the matrix is given, so 1, 2, 3, 0, 4, 7 and 1, 0, 0. See both the matrix order is same. When both the matrix order is same and they are equal means their corresponding elements are equal here. So here corresponding elements are x minus 1 is equal to 1. So from this x is equal to 1 plus 1, so which is equal to 2. So like this we can find the value of a x. X is equal to 2. Similarly here 2 is equal to 2 only. To get the value of y, here corresponding elements 5 minus y is equal to 3. So from this to get the y here, so 5 minus 3 is equal to y. So from this 2 is equal to y. So that implies y is equal to 2. So like this we can find the value of a y here. So similarly here 0 is equal to 0. Next corresponding element is to get the value of z. Here z minus 1 is equal to 4. So now, so z is equal to 4 plus 1. So from this which is equal to 5. So that implies z is equal to 5 here. So like this we can find the value of z. And 7 is equal to 7. So here 1 is equal to 1. 0 is equal to 0 corresponding elements. And here corresponding element is a minus 5 which is equal to 0 from this. So a is equal to 0 plus 5. So from this we get a is equal to 5. So like this we can find the values of x, y, z and a. The next question is in the section 2. So find the trace of the matrix 1, 3, minus 5, 2, minus 1, 5, 2, 0, 1. So take that given matrix that A is equal to, so here 1, 3, minus 5 and 2, minus 1, 5 and here 2, 0, 1. See, we have to find the trace of A. So trace of A is equal to, we know that, so here sum of the principal diagonal here. This is a square matrix of order 3. So trace is nothing but here. So trace of a matrix, trace of a square matrix. So trace of a matrix is defined. Trace of a matrix is defined as the sum of the principal diagonal elements. The sum of the principal diagonal elements. So in a square matrix, elements in a square matrix, so is called, so trace of a matrix is called trace of a matrix. Keep in mind this concept. So now trace of A is equal to 1 plus minus 1 plus, so 1. So here which becomes 1 minus 1 plus 1. So plus 1 minus 1 gets cancelled, which is equal to 1. So therefore trace of A is equal to 1. So like this we can find trace of any square matrix. So next third problem in the section 2. Given that matrix A is equal to 0, 1, 2, 2, 3, 4, 4, 5, minus 6 and B is equal to minus 1, 2, 0, 0, 1, 0, 0, 0, minus 1. Find B minus A and 4A minus 5B. Here the matrix A, so B minus A is finding. So that is B, the matrix B is here we have minus 1, 2, 3 and 0, 1, 0, 0, 0, minus 1 and minus the matrix A is 0, 1, 2 and 2, 3, 4. So here 4, 5, minus 6, 4, 5, minus 6. So when you subtract the corresponding elements here, so minus 1, minus 0 and 2, minus 1, here 3, minus 2 and here 0, minus 2. So here 1, minus 3. So here 0, minus 4 and here 0, minus 4 corresponding elements and 0, minus 5 and here minus 1, minus of minus 6. So finally we get, so which is equal to here minus 1, minus 0, that is minus 1, 2, minus 1, 1, 3, minus 2, 1. So 0, minus 2, that is minus 2 and 1, minus 3, minus 2 and 0, minus 4, minus 4 and minus 4, 0, minus 4, this is also minus 4, 0, minus 5 and minus 1 plus 6, that is equal to 5. See, like this we get the matrix B minus A. Similarly 4A minus 5B here. So all the elements in the matrix A is multiplied by 4 here. So 4 into 0, 1, 2, and 2, 3, 4, and 5, 4, 5 minus 6. So minus 5 into the matrix B is minus 1, 2, 3, and 0, 1, 0, and 0, 0, minus 1 here. So which is equal to all the elements in the matrix A is multiplied by 4. That is 4 into 0, 0. 4 into 1 is 4. 4 into 2 is 8. Similarly here 4 into 2 is 8. 4 into 3 is 12. And 4 into 4 is 16. And here 4 into 4 is 16. 4 into 5 is 20. So 4 into minus 6, that is minus 24. This is a scalar multiplication minus. Again multiplying with 5 here. 5 into minus 1, that is minus 5. And here 5 into 2, that is 10. 5 into 3, this is 15. And here 5 into 0, 0. And 5 into 1, 5. 5 into 0, again 0. 5 into 0, this is 0. And 5 into 0, 0. And 5 into minus 1, this is minus 5. So see here, the subtraction is equal to, we get 0 minus 5, minus of minus 5, that is plus 5. So here 4 minus 10, that is minus 6. I am writing directly here 8 minus 15, that is minus 7. And here 8 minus 0, that is 8. So 12 minus 5, that is 7. And 16 minus 0, that is 16. And 16 minus 0, again we get 16. And 20 minus 0, that is 20 we get. And minus 24 and minus of minus 5, that is plus 5. So minus 19, like this we get 4A minus 5B matrix.